This is not our regular cold open, and the reason for that, and I'm also not your regular host, my name is Bob Therriault, and I quite often edit the episodes of Arraycast. Now, I'm off on vacation for a few weeks, and as a result, we were looking at ways that we could fill in, because if there's nobody to edit, there's not going to be much of a show to put on. And looking back through the old episodes, one of the things I saw was that the very first episode we did, that a lot of people have never heard, was a really excellent, motivating episode. So if you know somebody who is interested in array programming but has not learned about array programming, you might want to steer them towards this episode. If you're a regular listener who has not listened to the first episode, you might want to listen to it just to see how we all started out. But in any case, the following will be an episode about array programming, our first episode. And in 2 weeks' time, our next episode will be about learning array programming. If you know somebody who's interested in array programming but hasn't yet learned it, these 2 episodes might be useful for them because they might be a way into learning about array programming, which, if you're listening to this podcast, I think you're probably already in, but this is a way for us maybe to grow the community a bit. So with that, welcome to our first episode of Arraycast.
I want to share with you a tiny origin story that literally no one else in the world knows. There's an example there of a function being applied to a list of strings: cow, sheep, cat, dog. I've often used that list of words in demos and code examples. It comes from a school review in 1965. My friend was introduced. Michael Simpson will now say a few words. Michael walked up to the microphone and said, "Cow, sheep, cat, dog."
All right. Welcome to the first episode of Arraycast, a podcast about array programming languages and the array programming paradigm. My name is Conor Hoekstra. I'll be your host for today, and I think all of the following episodes. And we're going to go around and do brief introductions with my 3 co-hosts. We'll go in the order of Stephen, Adam, and then Bob.
Hello, I'm Stephen Taylor. I was shown APL a long time ago, hundreds of years ago, I think, back in the days of time-sharing services and teletypes. And I immediately liked it better than any other kind of programming I'd ever seen. I did my first email messages on an APL system, actually written by a guy I'm still working with. I became an APL developer. I moved on to other kind of work, but about 20 years ago, considered I really hadn't had anything like as much fun as I used to have doing coding in APL, and came back to it. I edited Vector, the journal of the British APL Association. And for the last few years, I've been the KX librarian, working with the Q language, all part of the family.
And I'm Adam Botsevsky. I have been doing APL for pretty much all of my life, and that means about a third of a century by now. For the last 6-7 years, I've been doing it so professionally. I work for Dialog Limited and mainly working on APL tools of various sorts and helping people. And I also do some teaching, create some teaching materials, take care of some social things.
And I'm Bob Therriault, and I've been playing with Jay. I'm not professional. I'm just sort of an enthusiast, and I've been playing with Jay for about 19 years. And sort of active in the community, and I've talked to lots of people, participated in conventions, those kind of things. So, yeah, I feel like I'm a little out of my league in terms of expertise, but it's a different language, so that's good.
If you're out of your league, then I'm drowning. So previously mentioned, my name's Connor. I am completely different than your 3 co-hosts. I'm a professional C++ developer. I work at NVIDIA on a open source suite of libraries called Rapids, which is basically we're focused on GPU accelerating data science. So I do no APL or J or K or any array programming language professionally, or, I jumped into this a year and a half ago. So I'm definitely going to be the beginner on this podcast, asking all of the questions that hopefully the listeners have. And yeah, so I guess the goal is that we tried to get representation from across three of the primary array programming languages. So Adam is sort of representing APL, Bob is representing J, and Stephen is representing K, even though across the board, everyone's got experiences with these three different languages and other languages. And I'm going to be asking all the questions and learning just as much as the listeners. So I think the idea for today's episode is we're going to each spend 3 to 4 to 5 minutes explaining why we love array programming and or one of the array programming languages. And we're going to go from there. So in the same order that we did introductions, let's start with Stephen and tell us, why do you love the array programming paradigm?
It's a lovely question, and I got asked some years ago to explain this one, and I found it very confronting when I reflected on it, because I was forced to confront that I don't really think of myself as a very serious programmer, although I've spent much of my life being paid to write code. I know guys who are like deeply into algorithms and efficiency and getting the most out of the iron, and none of that stuff touches me at all when I reflected on it candidly. What I found when I looked into it was I just love the way it looks. And that feels kind of dumb, but you see a really good program on the page and I love it. And I find that beauty more in the Iversonian languages, in APL, in Q and K, a sort of conciseness, a correctness of it. And it's the same kind of joy I get from a really good line in poetry, or a really good piece of poetry, which just, I think, nails it. And you look at it and you say, that's everything that needed to be said on that, and it's completely there. And I get that experience in looking at a few lines of APL or K more often than I do in any other language. There's that Leonard Cohen song, isn't it? I came so far for beauty. He's musing on how his quest for beauty, I left so much behind. I practice in my family, his work, the people he loved. And I thought, yeah, it's an aesthetic thing has pulled me this way. And while at first I thought, that's kind of strange, it's kind of weird. I mean, we program for money, we need to get stuff done, it's a practical thing. Over the years, I've come to think the aesthetic impulse it drives us in our lives and in our work as developers. We have a sense of rightness. We have a sense of what's fitting, and we rely on it in writing and developing code to guide us, to know what we're doing. And I find that very, very intensely working with the array languages.
Yeah, I can't agree more. One of the most beautiful languages, if not the most beautiful language, that I've ever seen is APL, and there's something to be said about J and K as well. But let's hop over to Adam. Why do you love the array programming languages?
For me, it's definitely the expressivity. It's I have these patterns in my mind of what I want to do and how I want to do them, and I'm able to write them down. So for me, APL is very much a language like the human languages, like English is, and being fluent in this language and being able to express myself in this language, it just allows me to speak out to the computer and write out to the computer what it is I want, and then I get exactly that. I just like we don't have to define every nitty-bitty detail of the words that we use when we speak in English. So too, I don't have to define all those tiny little pieces for the computer. Rather, I can use these blocks very much like playing with Lego, and I put them together, and it just works. That's definitely what makes it for me.
So we have beauty in poetry, expressivity, and just being able to put on the page what you're thinking in your brain. How about you, Bob? Why do you love the array programming languages?
Well, I'll bring math into it, because I one of the big things for me is that they're executable mathematical notations. So you think, well, okay, any programming language you're going to be able to express mathematics with it, and that's true. The difference is with the array programming languages, the specific things that you're doing with either numbers or characters is down to single or small groups of functions and modifiers. And what that means is if I want to add up a bunch of numbers, a string of numbers, I don't need to start writing loops. I don't need to start declaring variables. I don't need to do anything else other than write a plus sign, a forward slash, and a backslash in J. And I've just, well, in that case, I've actually scanned it. If I just want to add the whole list together, it's just a plus sign and forward slash. And now I've got the total. And it's no harder than writing a sigma on a piece of paper and saying that's what I want to sum up, except now I can put it in a computer and it gives the answer back to me. Not only that, if I want to change the plus to a multiplication sign, which in J is an asterisk, now I've got the product. So I don't even have to learn a different way of expressing adding up a list. I can make multiplying a list. I can make it dividing a list, whatever that would mean. The thing that allows me to do is I will recognize patterns. And Adam brought up the point about patterns. You start to see patterns. It becomes like a telescope would be to a 16th century astronomer. You see quicker these things that are out there, and you think, well, no, if I multiplied stuff together, I'm aware of how, I know how Gauss did it when he was in grade 6 or whatever. But the point is you can actually go in and discover things like that because those patterns pop back at you. And if you want to change it, it's interactive. So you just change it and you get a different answer right away. And it's amazing how fast that tunes your mind into looking for those kind of patterns. So it becomes, you get the advantage of the unreasonable effectiveness of mathematics, because essentially it's a mathematical language that you get to interact with a computer, and you don't have to do the heavy lifting. The computer does it. Well, I shouldn't say you don't have to do the heavy lifting. You do the really heavy lifting. You're looking for the patterns. The computer does the calculations. And I find that's what I love about array programming languages.
It's interesting that you say that, too, because I can 1,000% appreciate what you just said, but I feel like until someone actually plays around with a J or a K or an APL REPL where they're typing things in and getting instant feedback, it's like trying to explain the Grand Canyon to someone, or even showing them a photo like, it's just sort of a hole in the ground. Like how amazing could it be? But until you're standing at the edge of it, like actually looking at it, you can't fully appreciate like how powerful it feels to play with that environment. So yeah, all three of those are awesome. I mean, I could spend an hour, but I'm going to keep it to 2 minutes on why very quickly I've fallen in love with primarily APL, and I'm learning J at the same time. But Ken Iverson, the creator of both APL and J, everyone that is familiar with the languages knows he won a Turing Award in 1979, and his famous paper, Notation as a Tool of Thought, popularized this idea that the notation that he's created, which initially wasn't designed to be a programming language, it was designed as a notation for explaining algorithms and teaching. It affects the way you think. But I think what's not completely captured by that idea is the extent to which it changes the way that you think. As a primarily imperative, C++ developer, I started learning functional languages like Haskell, and that definitely changed the way I thought. But then when I went from Haskell to APL, it was like a whole other order of magnitude. And it sort of speaks to, everything that everyone said at this point. Adam mentioned it's the expressivity of it, but the primitives in the language are what I think of as algorithms in C++. But when you're programming in a language like C++ or Python or Java, you're reaching for for loops. You're reaching for if statements and while loops and these keywords and building up something that eventually is expressive. Whereas in APL or in J, you're reaching for algorithms. You're reaching for a reduction, a plus operator, a partition. Yes, technically there are, if, keywords and for keywords. I basically never use them. And whenever you're solving a problem, you're reaching for algorithms. There is no better, in my opinion, environment or quote unquote playground to learn algorithms, because that is what the primitives are. And as soon as you're constrained to that, the way that you start solving problems is just, massively different than what you might do in a language, even like Haskell. Like Haskell's my second favorite language after APL. But there's just certain patterns that you're only going to pick up from being forced to sort of think in this like array thinking, this notation as a tool of thought. And on top of that, yeah, it's just the most beautiful language I've ever seen. And it also just makes, like, when everything's a single symbol, like when every primitive is just one tap of the key, like a finger on the keyboard, it changes the way that you develop. Like writing an algorithm in C++, it takes multiple lines of code. There's a lot of noise, semicolons, colons for namespaces, parentheses. Once you get something working, you're not going to immediately go back and then try and do six other ways to solve the same problem, because there's so much boilerplate on top of it. Whereas in APL, you solved your problem in like 6 keystrokes. Okay, maybe I'll go try a couple others because it's only 4 or 5 more keystrokes. And it sounds like that's silly, but it actually does change the way, I recently gave a talk where I showed 8 different ways to solve a problem. I'm not going to do that in a language like C++ because I got tired after solving it the first 2. And I just I profiled it and I chose the fastest one. But who knows, maybe the 7th solution that was not as intuitive based on my knowledge set, was actually the best one, but I never got there. And so at this point, I'll just let anyone jump in and comment on other people's, answers to the questions, and we can go from there.
Steven said that it's kind of like poetry. And it reminded me, there's an old article from 1977 by Alan Perlis called In Praise of APL, A Language for Lyrical Programming. So I guess you're not at first to think of APL as poetry.
That's one of my favorite papers. And I forgot to mention, I actually meant to mention Alan Perlis. So for those of you who don't know, I believe he's the first, was he the first president of the ACM? I think that's accurate, but he's a very well-respected individual in the community. He also has a quote that says, "A language that doesn't change the way you think is not a language worth learning," which I think he was saying that with respect to APL, or at least I'd like to think that, because APL changes so heavily the way I think about programs. Bob, you were going to hop in and say something.
Well, I actually, the same sort of thing that Adam was going to mention was about the poetry. I think that it is very much like poetry. Other approaches to programming a computer feel to me more like prose. You're sort of adding on things all the time, describing what you're going to do and moving through the process. Whereas I find with the array languages, I'm pulling stuff away. I'm trying to get down to that core of what's going to work. And that core feels to me an awful lot like poetry, because you're starting to become more and more precise with the words you're using and the order you're putting them in. And all these things affect the way, certain types of poetry, the way it lays out on the page is important. And honestly, when I'm really in the moment and I'm programming, I get that kind of the same feeling as if I'm trying to be so precise with my language. It does the same thing. And you were talking about how you would try something several different ways. Well, it gives me that exact feeling, because when you're in that flow, you are looking for other ways. Could I change this? Could I change that? And it really draws you into the art, I think, of programming, which is I find it so neat, so fun.
As a New York poet, I like to quote on this, Bob. It is a privilege. It is a privilege to learn a language, a journey into the immediate. It's Marilyn Hacker, of the family names there, I'm sure.
What year? Maybe that's where Hacker comes from.
I'd like to pick up on what you were saying, Conor, about the boilerplate and the noise. Because I get this feeling of like quietness when working with APL. Just like Bob was saying, I'm just working with the core of the problem. I don't have to generate all this distracting stuff. Well, I once heard a C programmer say, well, I don't really get this thing about getting rid of loops. I can write for loops in my sleep. It's sort of like, yeah, we'd like you to wake up.
It's funny you mentioned that. Actually, I have the responsibility for some code that part of it generates some APL code in a proposed extension to the language. And you're talking about somebody being able to write for loops in their sleep. Somebody reported a couple of edge cases that were buggy in my code. And I looked at the code that's written. It's about 150 lines or so. And it was complicated stuff. I went to sleep and I had a dream. And in the dream, told me how to approach this a whole different way than I had done before. So I woke up, I sat down at the computer at 6 o'clock in the morning, and by noon, I had rewritten the whole thing from scratch. Pretty much nothing. I kept like 7 lines of code that were kind of tangential to that. And it was all correct. It passed the QAs. Like that. So sure, you can write for loops in your sleep, but I can write entire correct programs in my sleep. Behold the power of expressivity in APL. I could remember enough details from a dream to just go and write it down.
I'm always amazed how much programming I do in my sleep. And it literally is that sort of a thing. I'll have worked, through the day on something. And when I say work through the day, when I'm programming, I literally play. I go in and I'll try something out and try something different, try a bunch of different ways. And it's just like, the way I know it's not working is if I keep adding things. Honestly, if I just keep adding things to fix this part of it, I know in the end it'll work, but it's not actually, I haven't got to the core of it. I had a math prof that said once the solution to, mathematical proofs or understanding a mathematical problem is to strip away everything else that's not the problem. And then you have the solution. And I think that there's so much of that that's true. When you play with it for a while, and I guess it gets back to this playing part, you play with it a while, you're seeding your mind with all the different things. If you don't recognize them consciously, subconsciously, you pick them up. You go to bed. I wake up about 5 a.m. thinking, oh, I could do that. And then it's a struggle to get back to sleep because I want to jump upstairs and start hacking and find out. And what I found is more effective is actually thinking about it for a little bit, going back to sleep, getting up, and then I've got energy. I can go at it. And sometimes it's right and sometimes it's wrong. But that's the nature of looking for patterns. You don't always get them. The nice thing about the array language is you can tell really quickly whether you're on or off. And if you're on, you can chase it down pretty fast.
Yeah, there's a Richard Park, who's going to be a recurring co-host on this podcast. He has a YouTube channel, and he does a thing where he solves these Perl weekly challenges every once in a while and just records it. And his goal is not at all to show the optimal solution. It's just to show, what it's like to iterate and build up a solution really quickly. And so many of the times what I do afterwards is I follow it along, I type along with them, and then I will like start stripping away and trying to replace. And like I'm going to make a YouTube video at some point that shows that he has this really long expression and you can remove like 12 characters with a single max scan. It's the videos are still amazing because you're seeing someone that knows the language and how they sort of navigate it. But that's this topic is that you're trying to strip stuff away until like certain times you'll look at a solution and I'll think in my head, this is not optimal. Like it's just, there's too much APL here to be solving what is a very simple problem. And I just need to go and think about it for, an hour, a week, and just sort of like in the back of my head, how could I do this separately? And that's the thing is because I'm on my APL learning journey, I started off by just knowing just the basics, the reduces, the scans, the reverses. And then every once in a while, I'll learn one of the new primitives that I just haven't learned. Like probably the most impactful one that I learned recently was key, which is an operator. So it's a higher order function. It's similar to like a SQL group by or a group by from a functional language. And, so previously, if I needed to find the maximum occurring element in a list, I'd do some sort and then a grouping with are the adjacent elements equal? And it was beautiful. I thought, oh my God, this is in like 6 characters, I can build up what, you spell out the algorithm in another language. And it's more characters to spell out that algorithm than just building it up with the primitives in APL. And then fast forward like 6 months and I discover key and I'm like, oh my goodness, there's like a whole single character that you can use to like reduce that, 7 or 8 characters that I had. And so it's, APL J, I'm sure you can say the same thing about K. While you're learning it, it's like what you start off with is so powerful, and then you just continue to add to that. J, I discovered under, which I'm sure we can talk about in a future episode. But it's just when you need that certain thing and it's there, it's just so beautiful because it simplifies the solution that you have even further. And like Stephen said, it just ends up looking like poetry at the end of the day. And it's hard to explain over a podcast. But believe me, it is beautiful.
Under is one of my favorites too, because I always think of it as the tire change algorithm. Is you jack up the car, you change the tire, and then you let the car down. Well, under you do one operation, you do what you're going to do to it in the middle, and then you reverse the first operation. And it's so often used in so many things. Like in your life, you do that all the time. You open a drawer, you put a spoon away, and you close the drawer. It's just over and over and over again. And then you can incorporate this idea into mathematics, and it's incredible how powerful it is.
I really like the case of surgery under anesthesia. We literally say that in English, right? And then you wake the patient up again. That's the undoing of the action. But they're all the steps. We don't think about it. But this is our whole life is like this. Open the refrigerator, take out the food, close the refrigerator. You're taking it out under opening the refrigerator. But even heart surgery, under cutting up the chest, it needs to be sewn together back afterwards under anesthesia. You can use multiple of them. And these it's again that the Lego blocks, they're made so perfectly. They just fit together snugly, and you just know that this is the right way of building it.
And it becomes so irritating when you have that tool in an array programming language, and then I go back to my day-to-day, I get paid money to develop in C++, and then I hit that pattern, and then what do? I just sort of I sit there sadly, and I code the transformation, then I do the operation, and then I manually undo it. And so many times it's just like, I love C++, very powerful language. There's a reason it's been as successful as it's been. But just the joy of being able to reach for something that's the exact thing you need. When you go to certain other languages, you sort of, you have, what's the word, like jealousy, envy?
Yeah, I definitely have that. Sometimes I have to write some JavaScript, and inevitably I hit the same problem. I know exactly how I would do this in APL. And it's just long-winded thing in JavaScript, and my JavaScript surely looks very unusual. It says .map all over the place and .for each and whatever not, and one long line of code, and it just comes from frustration of not being able to express myself. I know what it is I want, but there are no words for it. It's not like I can't find the words for it. There are no words for it.
It's like translating poetry. You're trying to fit your words into another language's poetry, and it's. I guess the good thing is you know what you're trying to do with it, right? The fact that the other language might not be able to do it quite as fluently, but you do know what you're getting at, which is, to me, a lot of the times the tool of thought is that it creates the thoughts that you need. And then from there, you've got a language that can actually execute those thoughts.
So one thing that I'm sure that at this point, I'm not sure what percentage of our listeners are 30 minutes into the first episode of a podcast on array programming languages, and they've heard all of us gush about how beautiful the language is. And the first thing I heard about APL and friends was that it was the most unreadable programming language. It's sometimes joked about as a write-only language. And yet, we've just talked for 30 minutes about how expressive, how beautiful, it's like poetry. I'm pretty sure our listeners are just completely confused on either what we're smoking or or like how this is possible, like what has caused this dichotomy of people that are using the language just falling in love with it, and then everyone else that's looking in commenting that, oh, it's just line noise. How can we convince all of our listeners that what we're saying is there is really some beauty here, and it's not unreadable line noise?
Well, when you can read it, you write fewer tests. And that's a serious bottom line you get from it. So years ago, I was talking to Kent Beck about extreme programming, a methodology which he codified, which relies heavily upon the use of tests. And I said, okay, so what do you write tests for? This is like one of those Zen questions. And he said, anything you think might break. Anything you think might break. Fair enough. So when I look at my code, what do I think might break? When I see 2 + 2, I know that's going to evaluate to 4. I don't need to write a test for that. I need to write a test potentially for anything that I cannot see is correct. And when you write at the higher level of abstraction that you get in the Iversonian language is you can see certain things are correct. You use iterators to run through arrays and whatever. You don't need to test that. The interpreter's got it completely cold. So you write fewer tests.
Adam, Bob, do you want to add what your take is on why, if you've been learning J for, 15 plus, close to 20 years, Bob? Why were you not running away when you just saw punctuation instead of words?
I think the biggest thing initially was just to play around with the language and see what you could do with it. And certainly with J, there's sort of because I guess it's digraphs. You often your beautiful single characters in APL become 2 characters, and the second character is an inflection, which is either a period or a colon in J. And so you get a lot of periods, a lot of colons, and it does start to look a bit like line noise. But when I was a kid, we used to go down in Vancouver to Chinatown to have Sunday dinners. My dad had a lot of friends who were in the Chinese community, so they would tell you where the best chefs were. And when you go down to Chinatown in Vancouver now it's a little bit even a bit more widespread, but then when you walked in, everything that was written was in Chinese. The menus at the restaurants were written in Chinese. And if you don't read Chinese, that is incomprehensible. It's just like, I don't get this. But obviously, people can understand it if they read the language, and they can read it as easily as any other language. And my sense of particularly array programming languages, they're so short that you can keep a lot of ideas together in a relatively short space of time, which makes it actually easier to understand. So as much as somebody who doesn't read the language would look at it and go, you can't get that out of that. But if you get the chance to actually practice and learn the language, and there's actually not that many characters, that you have to learn what they do. There's a lot of, one of the things I like about the language is there's always a lot of little surprises how they'll take a character and use it in a different way. And you go, I had no idea you could do that. I mean, we talked about under. Under's one of those things. You see under, and then you see under happening all over the place, and now you see all the places you could use it. First time it's explained to you, go, oh, that's kind of neat. But by the time you get into it, that pattern starts to build. And then when you see under in a piece of code, you know exactly what's going on. And it becomes actually easy to read, but you have to learn the language before it becomes easy to read. And because it's so different than what the more traditional programming languages are, it's easy for somebody to look at it and go, yeah, well, I already know how to do this. And you do in a different way. But as you said about Perlis's code, if it's not changing the way you think, is it really worth learning a new one? You can pick up a lot of traditional languages, moving between Python and C and BASIC and any other, those type of languages. You start to get into Lisps and object-oriented languages, and it is changing the way you think a bit. But I find even more so with array languages, they really, as I said, they have this connection to mathematics that I find really attractive, and it tends to focus your mind.
It seems like there's an analogy in there too to like when you start to learn the digraphs or the APL symbols, you start to recognize patterns the same way that when we're reading a book, we don't spell out, HELLO in our brain and then, okay, that's hello. I know that word. Like our brain is capable of recognizing those 5 letters juxtaposed next to each other and instantly knowing the meaning of it. We don't have to work through character by character, parse that, put it together as a word, and then find the meaning of it. That's actually how we learn to read as children. We take our finger by character, we spell out the word, we sound it out. But that's when you start. Once you can actually read the language, you read very quickly, and you're even able to read and sort of decipher the meanings of words you've never seen before, which there's probably an analogy there. Adam, do you want to hop in on what your take is on the unreadability versus poetry of these languages?
Sure. I mean, I'm a little bit not qualified to answer because I grew up with APL much like, say, a child in China grows up with Chinese, and it's not foreign, right? So
how is that possible? How come what? Well, how did you grow up with APL?
Yes, I did. My father was a great APLer, and I was shown. I mean, I was taken along to APL conferences at an early age, and I would sit in my father's lap as a toddler, and then he would do APL and just building it up. So there's no real date when I started doing APL. It's just like it was always there, and so the symbols were never foreign to me. And then much with the same thing as we were saying with Chinese, there's a false sense of familiarity when somebody who says knows English or other European languages see a text written in Latin letters. They recognize those symbols, and any other symbols would appear very foreign. So say an Englishman looks at an Old English text written in runes, looks very foreign, even though the language is actually pretty close to what he's used to. And then you can take a language like Maltese, which is closely related to Arabic, but it's written in English letters, right? Latin letters. So you'd get a false sense of, oh, this is immediately familiar. But it's false because the language is entirely different, has nothing to do with it. Letters might more or less mean the same thing, or they might not. Right? There's even taking a letter in English like J and V, and then you go to German that have the same letters, but they have entirely different meanings in those languages. So here too, it's a matter of just being more open-minded and saying these symbols can mean something. And so I guess it's a cultural thing because we are very used to symbols. If you look around you, people look at your smartphone, increasingly interfaces are replacing words with icons everywhere. They're just little stylized symbols that often are not very good illustrations for what they stand for. Right? The home icon might just be a triangle these days, or a circle, or three horizontal lines is for a menu. But it's like taking the essence of an idea and boiling it down. And that's really what originally Chinese characters are too. And if you look at APL symbol especially, but also to quite a degree for J and also for K, the symbols are paired up with the functionalities, maybe not in a way that you can just go and pick up, but if somebody points it out to you, then you never forget what it means. They're mnemonic in that sense, just like the symbol at the train station that tells you where to go for various things. And as a little child, you learn them, or you know what the stop sign means. Right? There's nothing in a circle with a horizontal bar that tells you can't go. But once you know that, it just sticks with you. It just connects with something. So I think it's a very much people are afraid of going out of their comfort zone. But once they do, and they open their mind and they see the beauty, that's when they're sold on it.
Yeah, that's one of the things that in my first couple days of experimenting with APL, that I just absolutely fell in love with the language, because in mathematics, those that created the symbols for certain binary operations, we drew lines in the sand at where we stopped. So everybody knows that, plus is a cross and minus is a flat hyphen. And then we have multiplication, which then it actually gets a bit confusing, because in the textbooks as children, it's an X, but then when we get to programming, we can't use X because that's also alphabetical character, so we actually use an asterisk instead. And then division, we have to come up with, there's the two dots with a hyphen in between, but that also doesn't exist on the keyboard, so now we have to use slash, but that's not a character, so we can use it because it's punctuation. But so the point is that there's minus, subtraction, division, multiplication. We typically have a symbol for writing that on paper when we're in elementary school, and then also for typing it on a keyboard. But what about two very other common mathematical operations, minimum and maximum? Like, we just arbitrarily decided that those don't get symbols, which, like, you don't really ever pause to think about that. Like, it's just what we're taught, and so we just take it. Okay, that's fine. But like, why? Like, why did we stop? Like, we were, common binary operations and min and max. We just said, no, those ones you have to write out min and max. And then Ken Iverson in the 50s, he saw this, and I'm not sure if he was the first person in the history of the world to have this thought, and said, like, okay, that's nonsense. And so he created two symbols to represent min and max. And I was building up a slide deck once where I wanted to put all these binary operations, and I had the nice symbols, and then I got to min and max, and I was like, oh, wait, I got to type min and max out, 3 characters. And it looks so asymmetric that these first 4 binary operations is just a single character, a single thing to represent it. And that's just one example. But Ken Iverson, I think, has noticed that across, different domains in math, that we just we drew the line at some point. Summing a bunch of numbers gets capital sigma. Multiplying a bunch of numbers gets a capital pi. Any other, iteration with a binary operation? No, those don't get symbols. We're going to stop there. And he recognized this stuff, and he fixed it in his notation, which later became a language. But it's APL makes you, or array programming languages in general, it makes you sort of wonder, why did math make these decisions? And in my opinion, fixed a lot of it. It's unfortunate it didn't get adopted by all education systems, in my opinion, because I find complex math, or whatever domain you're thinking about, linear algebra, etc., it's easier to think about in terms of APL notation than it is to actually think about it in the notation that domain provides you with. That's just my take, but...
Yeah, even order of operations, right? The fact that the order of operations are consistent in APL, and it's just, if you want to change that order of operations, you just parenthesize. Otherwise, they go exactly the way they always do. You don't have to worry about PEDMAS or whatever kids learned in elementary schools. Yeah.
Some of it did get adopted, though. Iverson was a mathematician, and he started off by just making suggestions as to how normal mathematical notation could be improved. And today, it's fairly common to see floor and ceiling written in notation that he used for it, and even conditionals being so predicates mapping to 0 and 1 by putting them into square brackets is used on occasion. Also something he came up with, and that became an integral part of APL and J and K. They all agree on this, that any kind of predicate returns a 0 or 1. In a sense, APL is evolution. It was never somebody sat down and said, hey, let's make a new programming language. It's just a natural evolution of where math over centuries had added symbols for more and more things. It's a natural thing.
What's kind of interesting to me is it sort of took a lot of the mathematical symbols that have grown over time in history, and it broke them apart so that you could take plus and another modifier, and you'd get sigma, but then you could do the same thing. You didn't need 2 separate symbols for, summation and multiplying out a list. You just change the one little, in the case of J, we call them verbs, the one little verb that does the work, and you modify that, change the verb, and you change the way the whole thing works. By splitting it up, you can use those combinations. Adam was saying before, it's like Lego blocks. You literally can put a different Lego block with something and you get a very different result.
I think that's a power of it as well. All of these languages take concepts and generalize them. And the power of generalization is then there's less to learn. Right? If you learn in mathematics that a huge sigma means summation, and one day you see a huge pi, you have no clue what it means. Right? There's no indication. But if you learn that plus slash means summation, And then one day you see something new you have never seen. It says multiply slash. You know immediately that then this is a product.
Or maybe not immediately, but you can at least make a good guess that that's what it's doing. If you know that the slash and the plus slash is the reduction part of that operation.
Okay, so if you've seen plus slash and you've seen time slash, then one day when you see and slash, you will know that it means all of them, right?
Well, I think this is something that potentially like array programming language programmers or developers they take for granted of how explicit K, Q, J, and APL that they all make this is that when you see a reduction, it's right there. It's explicit. Maybe you could argue from the Q point of view because they've wordified it that it's not as explicitly clear, but they make there's a beautiful pattern in Q that the scan always ends with an S of the reduction form. So if you have a reduction that's a plus reduction, it's sum, and then the scan version of that is sums. And if you same thing for min and mins and max and maxes. That was one of the other things. Like in the first couple of days when I fell in love with APL, like coming from C++. There was a point in time where I had not made the connection between the different algorithms. Accumulate, which is by default it does a sum reduction, but you can pass it a custom binary operation to do a multiplies reduction, etc. But we also have algorithms like min element, max element. We have another one called count if, which counts the number of elements that satisfy a unary predicate. There's all these differently named algorithms that there's absolutely nothing explicit that they are reductions. It's just an observation you have to make. And there was a point in time where the idea of a reduction was not something that I knew. I didn't study computer science. I was not a computer science major. And even if I was, I'm not sure if that's something that's covered in an algorithms course. Usually they're doing divide and conquer, and they're not actually, doing these sort of functional higher order algorithms. And so at some point, I realized, oh yeah, because I watched a talk by one of my favorite speakers, Ben Dean, he has a talk called the Algorithmic Empire or something like stood accumulate, the Algorithmic Empire. I apologize if I got the name slightly wrong. And it shows how of the 90 algorithms in an algorithm header, like 77 of them are implementable in terms of a reduction. And that was where I was like, oh wow, this idea of a reduction, like they're everywhere. And it wasn't until I went to APL where when you see a summation or a product, there's always a slash. It's right there. Like you can't have a reduction without that slash, which seems like a small thing. So as Adam was saying, it's just you're obviously going to recognize it. But like coming from a language where that's not explicit, which is like almost every language. I mean, you could argue a lot of functional languages where you have generic folds and generic reduces. Like it's obvious from that point of view. But like Python, for instance, it has a reduce, but primarily you're using the custom sum and the custom PROD for product functions. It's not explicit. And I basically made that observation from learning APL, which I think that there's probably like a whole category of things that APL and J developers they just sort of take for granted, and then I come in and I'm, holy smokes, this is amazing, and everyone's like, okay, yeah, that's like basic 101 stuff. Like, why? That's not even why we love the language. that's just like children's play. And I'm just like, wow, this is great. So that was a little bit of a ramble. We should start to wrap up. So this episode we talked about why we love this paradigm and these languages. Potentially in our second episode, if you are intrigued and want to learn more, we'll dive in a little bit to what makes APL different than J, different than K, different than Q, and even other array programming languages. But are there any last comments and thoughts that folks want to say before we provide people with some resources and sign off for our first episode?
So you're saying we're going to do this again?
We'll see. We'll take a look at the stats. Honestly, I personally, even if we have 0 listeners, I know I'm going to learn a ton from these meetings. So I'm happy to do another one. But all of us are going to have different bars. My bars is at the ground level. You just have to step over it.
It's generally not a good idea with podcasts to have a goal of 0 listeners, but that's.
I like to set the bar low so I can overachieve very easily.
With Conor on this, not the goal of not zero listeners as a goal, but if we are finding this interesting enough to enjoy the conversation, it's worth doing.
And hopefully others will enjoy as well. My assertion is that there are a ton of folks that have heard of APL or heard of J or heard of K or Q, or just this paradigm in general, and that would love to passively listen while going for a walk or doing the dishes or while driving to and from work whenever we go back to driving to work, if that ever happens again. This is being recorded in 2021, mid-COVID. But they might not be curious enough to go and spend a weekend trying to figure out what do these symbols mean. But they're curious enough for sure to just passively listen to some folks that are super excited about the technology. And hopefully we manage to attract some of that crowd.
Well, I would say the only thing with J to remember, if you're looking to find out more about it, don't do a search of J, because you're not going to find it. God, just start with J software, all one word, and that'll get you into the site for J. But J on its own, it's kind of the curse of the one-letter languages. You have to figure out a way to get into them, and the first trick is not to search for the letter because it's unlikely you're going to find it. APL's got a bit of a jump on us there.
Even APL, there's a popular athletic clothing, I think, athletic propulsion lab or something that half the time I search for APL and I'm like, why am I looking at shoes right now? But maybe we'll kick this over to Adam, because you've got, I think, a list of resources or links that if folks want to, even before they get to the next episode, go and check out these languages. Where should they go to satisfy their curiosity?
Yeah, well, recently I, together with a bunch of friends, overhauled an old site called the APL Wiki, and you can now find it on just apl.wiki. And even though it's obviously APL centric, it does have also articles about Q, K, and J, and it has links to everywhere. So I think it's enough of a portal, just apl.wiki, and then you can take it from there basically. And there are links from the front page to all kinds of things. There's a link to something called introductions, and it's just a list of various people presenting their thoughts. There's an amazing article called Discovering APL, written by somebody named Stephen Taylor. Highly recommended. And there are also links to where you can try it out, and lots of examples of things. It's mainly on APL, but then there are links to K and J as well.
All right, so APL Wiki for starting portal, Google J software for J, also code.kx.com/Q for Q if you want to go straight to the Q source.
I'd just like to jump in, if I could, and remind people that if you enjoyed this first episode of Arraycast and you'd like to get in touch with us, you can send us an email at contact@arraycast.com or tweet us at Arraycast. And for more information on the array languages, you can visit arraycast.com, and there's a resource page there for background on the array languages. And if you enjoyed our podcast as much as we did, then head over to iTunes and give us a rating. It really does make a difference in how many people will find out about the podcast and helps to spread information about the array programming languages.
We'll sign off. Thanks, everybody, for spending an hour of your day listening to us ramble about this esoteric paradigm that hopefully will catch a few listeners to get interested, because if you want to be a programmer poet, this is the way to do it. All right. Thanks, everyone. And we'll hopefully see you in the next episode.
So that was our first episode of Arraycast. I hope you enjoyed listening to it. And you may have noticed that our signature sign-off, Happy Array Programming, was not on the first episode. Perhaps I'm going to make that a future question for some prize or something if we ever go down that road and start awarding prizes. But just to be completionist, for now, Happy Array Programming. Next, in 2 weeks' time, we'll do a podcast on learning the array programming languages, and I hope you join us for that. And that will be a new one. And then we will continue on with this journey that we're all on and sharing of exploring the array programming languages. Happy Array Programming.